Okay, let's look at how sequential logic works. This circuit has 3 D flip-flops and a few AOI gates. Okay, the first flip-flop is going to be the least significant bit, and the last flip-flop is going to be the most significant bit. Okay, so it goes by A, B, C. C is the LSB. Okay, A is MSB. Okay, so right at the moment, right before the start of the circuit, right before you turn on the power, turn on the switch, okay, before you turn on the switch, so that's a 0, okay, so that will go here, and go here, and it will clear the C, okay, and set the B and A, so 1, 1, 0. So when you run the simulator, most likely you will see when you start, you will see 1, 1, 0. Okay? Okay, then let me erase that. We also have a reset circuit here. This is the reset circuit. Okay, let's see how it works. So when ABC is 1, 1, 1, okay? How do you know? Because that's how we design the circuit. So that's 1, 1. Okay, it's an AND gate, so your output is 1. This is 1, this is 1, output is 1. Inverter, so that's a 0. So that 0 will set the C, will clear the B, and clear the A. Okay, so we'll set the C, will clear the B, and clear the A. Okay, so the moment the circuit sees output 1, 1, 1, almost immediately, okay, with very short pause, okay, you almost cannot see, okay, it will output 0, 0, 1 almost right away. Okay, so in other words, you probably won't even see that 7, okay, at all. Okay, 1, 1, 1 is a 7, right? And then will from 6, okay, jump to 1. Let's look at timing diagram. Okay, so when you start the circuit, you get 1, 1, 0, right? And because of the reset circuit, you see this moment, you see ABC is 1, 1, 1, right? And the reset circuit will right away, okay, output 0, 0, 1, right? And skip the 1, 1, 1. Okay, so now we have 0, 0, 1, and every time when you have a clock, rising clock, right, for the C, right here, right, every time you have rising clock to the C will change the state, will toggle, right? So if it was 1, it will change to 0. If it was 0, it will change to 1, right? See, every time clock, rising clock, C will change the state. Okay, then let me use another color for the B. Let's look at how B works, right? B, right here. You see the clock into the B is Q0, which is C0, right? So that means every time you have a falling edge of a C, because C and C0 is opposite, right? Falling edge of the C, your B will change the state. Okay. Otherwise, B's output will not change. Okay? Every time C falling edge. Okay, that's B. Okay, so almost a similar idea. A, okay, B naught is feeding to A's clock. That means every time you have a B falling edge, which is B naught's rising edge, right? B's falling edge is B naught's rising edge. You will change A output. Right? Okay, let's look at it step by step. At this point, I will suggest you ignore the colors, right, on the slides, because some people get confused. Just listen to my explanation. Okay, so the first slide is showing, the reset circuit. Okay, after the reset circuit detects 111, it will right away change the output to 001. Okay, and the second slide, then you had 001, right, previously, and we also know the Q naught is opposite of Q, so this is 1 opposite 1 and 0, right? So far okay. Then we also know, see, the Q naught is connecting to the D input. Okay, this is very important, and that's how the D flip-flop will toggle its output. Right? Okay, so we have a 0 waiting at the door, have 1 waiting at the door, and we have a 1 waiting at the door. Right? So every time we have the rising edge of clock comes in, this is the rising edge of clock, and that's my SLB, that's a C, and SB, that's A, right? And this rising edge will fit into the clock of the C. It will pass this 0 to the output, right? So your 1 will become 0, therefore your Q naught will change to 1, right? And because 0 to 1 right here, okay, that's a rising edge for the B, right here, rising edge to the B, and it has the 1 waiting at the door. The 1 will pass the output, 0 will become 1, and 1 will become 0, and 1 becomes 0. That's a falling edge, so we don't have in the clock for the A. So what will we have? We'll have 0 remain the same, and this is a new output. That's a new output. So we'll have 0, 1, 0 output. Okay, similar to the previous slide. Now we have 0, 1, 0. Right? Then we mark Q naught. That's opposite, opposite, opposite. Right? And that's also 1 because Q naught is connected to the input of D. And that's a 0 and that's 1. Okay? Okay, then the next clock comes in. Next clock comes in. Rising edge of the clock to the C. Okay? C, that's B, that's A. Right? Then it passes this 1 to the output. So 0 becomes 1, 1 becomes 0. And because it's 1 to 0 is not the rising edge, right? So B did not change. B did not change. Output did not change. Therefore, we also don't have a clock for the A. So what is the final output? It will be 0, 1, 1. Okay, next. So 0, 1 1. Okay, opposite 1 0 0, and we'll have 0 waiting at the door, waiting at the door, waiting at the door. Rising edge of clock comes in. Okay, and we'll change. In other words, your C is always changing every time the clock come in. Right? In the B and A, you have to C. It's B, you C. Okay, so 0 to 1, 1 to 0, 0 to 1, and 0 to 1. Okay, you'll change the B. So you have a rising edge here. You change to 0, you change to 1, and 0 to 1 also has a clock right here for the A. Okay, so everybody change this time. 0 to 1, 1 to 0. So your final output will be 1 0 0 1 0. Okay, next. So you have 1 0 0. That was the previous output, and the opposite 0 1 1. Okay, and you have 1 waiting at the door. You have 1 waiting at the door. 0 waiting at the door, and the clock rising edge coming. Right, 0 to 1, 1 to 0. And because 1 to 0 is not rising edge, I don't have a clock for the B, and the B is not changing, therefore I don't have a clock for the A. So the new output will be 1 0 1 1 0 1. Right? And last, so 1 0 1. Right? Opposite, Q naught, opposite, opposite, waiting at the door, waiting at the door, waiting at the door. And rising edge of clock comes in. Right? And you change to 0, change to 1, and 0 change to 1, you get a clock for the B. 0 change to 1, 1 change to 0, 1 change to 0, you don't have a clock for the A. So the final output is 1 1 0. Okay, we'll see what happened next. So we had 1 1 0, which is 6, right? Then the opposite, 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 and waiting at the door, waiting at the door, and waiting at the door. So the next rising edge of clock, okay, it will change to 1, change to 0, and we don't have a clock for the B, we don't have a clock for the A. So the next output should be 1 1 1. But remember, we have a reset circuit here. As soon as this change to 1, as soon as the C change from 0 to 1, you get 1 1 1 here, right? And it will reset the entire thing to get start from 0 0 1 again. Then keep on looping.